documenting it, what
Yes.
people are using.
Okay,
Yes.
sure.
Okay, hello and welcome to Apropos. We're live and ready to talk about closure. Let me introduce the panel. We got Ray,
Hello.
Mia,
Hi.
I'm Eric, and our special guest today is Paula. Hi, Paula.
Hi. Hello.
So you're pretty well known in the closure community, but maybe you could tell us a little bit about how you got into closure?
Um, I think I fell into it. I was, I think I'd rewind maybe to early 2000s. I had a number of colleagues who knew much more about programming than I did. And I overheard them referring to functional programming a lot. And I was curious about what they were talking about, and one of them pointed me at the SICP lectures and said, like, if you go through these, you'll have a much better idea of what we're talking about. And so I downloaded them and didn't watch them all in one go, but sort of slowly got through them over time. And they were great.
Mm.
And I started trying to duplicate what I was seeing in languages that I knew, like C. And that meant that I was having to build up structures like global structures or something to try to hold the stack. And but I was really starting to get a sense of what Jerry Sussman and Hal Abelson were talking about. And, it really converted me. And so I was looking to implement things that way in future. And most of my work at the time was either C++ or Java. And if you look at my Java code from that time, it's it's really starting to look very functional.
Uh-huh.
Google released a library that looked very similar to the code that I was putting out um, around, like collection operations and predicates
Right.
and things like
And
this.
that was before the functional stuff in Java, right? Before
Yeah,
lambdas
yeah,
and
yeah. We were
streams.
we were on Java 5 at the time. And then even Java 6 didn't really have that. Um, and so over the next few years, my Java was getting probably more and more incomprehensible. But I started learning Ruby and Python and like really picking up on languages that included like a lambda keyword. Um, and then a lot of people were really getting into Scala. And so I started pushing in that direction. And the open source projects that I was working on, I was starting to incorporate Scala into it. One of the issues I had was that I was spending as much time getting my types right as I was on code. But I really did appreciate what the language was bringing for me. And then I was looking for a new role. I was an expert in semantic web, and this company was doing semantic web work, but they were using this new language Clojure, and that was Reveletics. I was speaking with the guy who ran the company, and he said, what do you think of Clojure? And I said, well, it's a Lisp, and I'm really interested in Lisp because of that SICP background. And it's on the JVM, so I figure it can't be too hard to pick up. And he said, great, get yourself a book on Clojure. We'll see you in a couple of weeks. And I worked with this great team who all knew the language well, and that included Alex Miller. Um, and my very first project, initially I had to do some Java things at that company, but my very first project in Clojure, I re-implemented something I'd previously built as an open source system, and it was far more capable. I did it in a fraction of the time, and I did it in 90 lines of code, whereas previously I'd implemented a less capable system in a couple of thousand lines of Java. And that kind of converted me. I never really looked back. And I've written in other languages since, but I always want to come back to Clojure because it's just a much more comfortable system. I can accomplish a lot more, and it's um, yeah, it's a language which gets out of my way. Every time I have to use another language, I've got to learn a whole syntax. Why do I have to learn syntax?
For sure. Even working in Haskell, I had this syntax. And Haskell's a great language, right? It's very functional. Um, but I had this syntax cheat sheet that was like 8 pages long. And it was constantly like, what does this thing mean? And oh man, it's so nice to get into Clojure where it can fit on one page and you have everything. There are some little gotchas with like some of the some of the symbols that are hard to Google. But Clojure is very clean.
I'm pretty familiar with most of the symbols in Clojure, so that helps. And that's
Mhm.
years of practice. But I do have cheat sheets around, but that's for things like Cider or Emacs, or
Yeah.
but not
Yeah,
Clojure.
I know that people have it memorized, and I do not. I have a little card that's taped to my computer that's got all my cider commands that I have to look up.
I know like 3 or 4 Cider commands, and that's it.
They're all written down.
Um, so speaking of cider, can you show us your editor setup?
Sure. I was saying before we started broadcasting, it's not particularly um, fancy. Let's see.
While you're doing that, Paula, one of the things that, in terms of like the syntax, I think probably there's a whole bunch of macros in Clojure that have syntax, and that's the one small difference. You know, things like post walk and even just lets and stuff like that. There are little bunch of DSLs
All the
that kind of
destructuring.
the destructuring where we did that
Structuring.
little
We did
library,
that, yeah.
that
No,
was
well,
a
you
bit of
did
fun. Yeah,
that.
but okay, yeah.
When it comes to anything like that, I tend to go to the original source and try to figure out what they're doing so that I can
Yeah, I mean it's
understand
fine,
it.
but core async is a bit trickier, But again, you can do it, but it's, you know,
Core async is hard to read the source.
yeah.
It's often easier for me to um, macro expand. Like I'll write something simple, I'll macro expand it and see what it's doing, and then I go back to the source.
Yeah.
We're kind of examining our assumptions about what is and isn't easy syntax to reason about right now. On my team, we have an intern.
Mm.
Uh,
Right,
Mm.
right. Yeah,
And
yeah.
we have an intern who has never seen Clojure, seemed kind of shocked that he
Mm.
was going onto a Clojure team. Was like, what is this? And so it's been interesting thinking about what is like it feels intuitive to us because we've been doing it for so long, but we're having to he's having to completely retrain his brain on how to think because they don't do sick P. He never did sick P. They didn't teach it.
Oh, so he doesn't even have the basic lambda
Oh,
calculus stuff.
huh.
Yeah.
Yeah,
Yeah.
That's the hardest part, I think. I think that's why Paula like was a perfect lead up, because
Yeah.
if you've got all of those kind of bits of knowledge about functional programming, then yeah,
yeah.
it's actually just a blessing to have closure. But
A lot easier to start with the paradigm, and then Clojure syntax is it lends it's built off of the paradigm, and so it feels more
Yeah.
mm.
intuitive if you come to it from a functional background.
Well,
Hmm.
Or
SICP
no background.
teaches.
Sorry, Paula. Yeah.
Yeah, that too.
Sorry. I find that it teaches you how to think about code functionally, and actually, the thing that I learned most from that is this idea of wishful thinking when you're coding.
Hmm.
I want to write a function and I need an operation right here. So let's just pretend we've got it and write the rest of the function. And now this thing that I was pretending that I had, let's go and write that and drill down that way until you're at, you've hit the component elements which can build something. So I'll tend to write top down.
Yeah. Yeah, that's true.
And SICP taught me that approach. But I think coming in through Scala and then to Clojure, these immutable structures, or functional data structures are they're in a really important paradigm that I think, um, functional programming doesn't really get you there until you incorporate functional data structures. And
Sure.
one of the beauties for me in Clojure is how those structures are built into the language. They're part of the syntax. I said there's no syntax, but there's a little bit of syntax, and they're trivial it's trivial syntax to have it as a part of the language. And I really value that part of Clojure as much as anything else. The fact that it's built on these data structures.
Mm-hmm. Mm-hmm. Yeah, I remember feeling that in like missing that in Haskell. That this just seems so poor. The data structures you have a list, linked list, built in,
Well,
and you can pull stuff in, but like nothing's based on it, right? So like your other libraries aren't going to be using it.
I love the fact that I can use square brackets and it's a persistent,
Vector.
persistent
Yeah.
vector internally.
Mm.
So jumping between languages, the word list means
Different things.
different things in different languages. But yeah, you've got a persistent vector if you're using square brackets, and that's a much more complex structure. Internally you've got trees of arrays, but um, you don't have to worry about that, and it's implemented really efficiently. Um, but yeah, with what you were saying earlier, Mia, were saying how trying to think of what syntax looks good to newbies or to anybody working with code. And I was just thinking, I can be very opinionated when it comes to my Clojure code or the code I'm working with. It's awkward for me sometimes when I pick up on someone else's code and have to work with it because I'm thinking, I want to write it this way, and I've really got to work in with what, how they've implemented things or the structure that they like to build in. And I was just thinking when Eric asked me to pull open like an editor, the sort of the way my code will look in an editor, I'm sure it's going to look very different to the way other people write Clojure. Um, yeah.
I
Well, let's
guess
see it.
yeah.
Yeah.
So I believe I'm sharing now. Can you see it?
Yeah, we can see
Yeah,
it.
yeah.
Okay.
So you
Uh,
got Emacs.
yeah, this was the library I built a few weeks ago for something else. I was finding that I had to keep converting between time structures. Uh, I was in a system that was talking to a database. I had data coming to me through a WebSocket. I had um, just a lot of different places that time could come to me. And sometimes it was showing up as a Joda time object. Sometimes it was a Java time instant. Sometimes it was a string. And I was just having to convert constantly.
Hmm.
And so I ended up writing some protocols to automatically convert one to the other. And then it totally got out of control and I implemented most of Java time,
No.
which Ambrose has, um, Ambrose has gone and implemented wrapped most of Java time, which is great, but doesn't do a lot of these auto conversions. So I'm thinking what I'm doing does overlap significantly with his work, but it also complements it. So I was hoping, I don't know if he watches this, but I'm hoping to get in touch with him and ask if there's anything I can take out of this and maybe move into his work. But
If he doesn't, I will connect you too. So between the two of you, you've now rewritten all of Java time.
But yeah, so this thing is like full of protocols on how to do things and then like implementing it and switching between them as well. So like anything in here can take instance or local date times, temporals, and it attempts to switch between them wherever it's useful to do so.
Mm-hmm.
Um, yeah, so I can take a date and add a number to it. And if it's a date, it'll probably try to add days. But if it's smaller, it might be trying to add seconds. So
Mm-hmm.
it automatically makes assumptions. It's very opinionated. It makes assumptions about what size durations you're likely to talk about. If you try to take a time that does not have a time zone associated with it, it's going to presume that you're talking about UTC.
Mm-hmm.
And then if you need to convert back out into something with a time zone, it if you haven't explicitly said so, it'll say, well, this is now a UTC thing. Because we're getting instants all the time, and the instants almost always are UTC.
UTC, right?
And so having opinions like this has been really useful because, every time I see a date and time that doesn't have a time zone, that, for me anyway, and in all the projects I work on, that always means UTC. Yeah, so this is a system that makes a number of assumptions about that, but it also does a whole lot of automatic conversions between them. And
So, do you find that those assumptions like make things easier? Because I sometimes like in a big code base with a lot of people working on it, I find that these kinds of assumptions, like assuming that, like you said, if I'm adding a number to a date, I'm probably adding days.
mhm.
Like those kinds of assumptions start to like like almost more exceptions than there are cases where it fits. And
So
and
what I try to do is follow the API. So I
mhm,
can say, I want to add 5 days. And that's easy and that's an API call. But
mhm.
sometimes I just want to say, well, it's a number of, it's a date that
Just
goes all
plus
the way down
five.
to days. I want to
Hmm.
add 5 to it.
Hmm.
That
Hmm.
likely means 5 days. And so I'll have a long as a possibility for that argument that's coming in instead of the duration object of days, minutes, months, whatever.
Hmm.
And so on that occasion, if I see I've got a number instead of a duration, then the number is where you apply that that assumption. But without the assumption, you wouldn't be able to add a number and yeah, long at all.
Right.
So it doesn't hurt to have the assumption. And if I never used that assumption, then maybe I could just drop that version of the function.
Hmm.
But typically I put this in because that is the assumption that I'm using all the time. Um, and I'm finding that it's really annoying to say, 5 seconds every time I'm adding to a time. It just seems like I've got this boilerplate in that I'm adding seconds every single
Mm.
time. Why not just add 5? Because whenever I'm adding a number, it's always seconds. And so,
No,
for
it
that
makes
sort
sense.
of object, I'll just say, well, if I'm always adding seconds, let's just presume seconds whenever I see a number. But if I see a duration, then, I can drop to doing that.
But what if you're not adding seconds? Does that ever happen?
Occasionally, like I want to add an hour. In that case, I just say add 1 hour. An hour is a duration. So you just say hour one.
Okay.
And yeah. but it's just nice to not have to explicitly state seconds every single time.
So how are you, how is this assumption encoded? Where is the, oh, I see. It's right there. It's actually
Well,
here.
yeah, it totally
I
depends on
see
what
it.
you're
I see
trying
it
to
right
do.
there. All right.
So temporal amount. Okay, so the things here, I've got, let's see, temporal, if I jump between some of my, so arithmetic time, here we go. That's an example of it. So if I've got an instant, there are certain things where I can say I'm adding these sorts of things to it. Otherwise, if I've got a V here, this general, if I just say plus, it tries to figure out if it's a duration. Well, it tries to create a duration out of it.
Okay. So that's another
And
protocol method to
yeah, and
duration.
so to, duration is designable, let's see, temporal. Um, so somewhere up here, I've got it. So where does to duration first show up? To duration, here it is. Temporal amountable. So if I do a duration and it's on a duration, then I just pass it through. So if I've said, 5 minutes and I pass 5 minutes as my object, then I'm adding 5 minutes. But if it's a long, then I'm turning it into millis.
Okay.
Um, that sort of thing. If it's a string, durations can be parsed. There's a particular syntax.
Oh,
So I
So
say
that's where you would say, that's where you would
P5S,
say
and that's
1
5 seconds.
hour.
What was that, sorry?
That's where you would say 1 hour is you would put that in as a string and then it would parse it as a duration.
I actually just use the standard duration parser. Um, so
so whatever it does.
yeah, I can't recall the exact syntax. It's like it might be a D. No, sorry, P, T, and then you have a number followed by a letter indicating what it is. So like 1 hour, 30 minutes would be 1H 30M. Um, there is actually an ISO standard for that, but uh, I tend not to use that. I'll be using I'll create a duration object, an appropriate duration object. But
What
yeah.
what is this for? What did you
That's what I was just
Well,
about
I
to ask.
kept getting time. So sometimes I'd get a time out of a database and I needed to add 5 seconds, literally 5 seconds. Or I would get a time given to me over a WebSocket, and occasionally that would be, well, usually that would be in a string, so an ISO string, and it would be an instant. Other times I would get a coming over the WebSocket, say Nippy was used for sending something over the WebSocket. I could get a Joda time object. And every time I thought, oh, I'm handling another data type now, I've got them all. A week later, some other API interacted with me and I would get a different type of time. And I got sick of it all and I started putting it into a protocol to automatically convert everything into the time that I needed to work with. And then I got it working. This was at work. I got it working. And then I kept seeing all these extra things that'd be nice to have. And I added some of them in. And I thought, I would really like to have this done properly, not just covering those few cases I needed for work, but to actually write it out fully. And so I took a weekend and did it.
Okay.
And it extends Joda time, but that's why I've got this when accessible macro on it, because if Joda time's available as a dependency, then it'll extend it. But if it's not, then it leaves it alone. That way, if you don't have Joda time loaded, then this will compile just fine.
Nice. And is
Yeah.
this available, this library?
It is, but like I said, it's competing essentially with Ambrose's system, which is really comprehensive, and I would recommend people use it. But I'd like to talk with him about how to
merge them.
um, like, how I could take what I've done here, mostly protocol based, because they're faster than multi-methods. And I like the approach of protocols in general. I guess it feels more like polymorphism. Um, if I can take some of what I've done here and merge it in with Ambrose's work, but I'll have to have a conversation with him because there's a lot in here. Yeah. And so it's not just wrapping the Clojure, so the Java time, it's also like extending it into this automatic conversion everywhere.
Here's a question.
Mhm.
How many, not counting strings and longs like timestamps, how
Mhm.
many types have you encountered that represent time
Not a
on the
lot.
JVM?
There's Java date,
Uh-huh.
Java util date, Java SQL timestamp, which extends Java util date. Then there's Joda time on the screen in front of me. We've got the readable instance, but there's other types of Joda times as well. So Joda time covers a few different localized times as well.
Mhm.
Um, then there's everything in Java time.
Java time. There's like
Uh,
Java calendar.
so calendars are part of time, and I do
Oh, is
cover
it?
the calendars in here. Um, and some of those are interesting to learn about, like the Buddhist calendar and the Mayan calendars,
Mhm.
and they're all covered.
Okay.
Um, so like down the bottom somewhere. Yeah, so if you can explicitly call for things. So the Hijra calendar, Japanese calendar, um, Minguo, Thai, that's a Thai Buddhist. Um, so there's a number of different calendars that Java supports.
Cool.
Um,
You
they're
uh,
Never heard
all
about
you
those.
mentioned
integrated
public.
in, and they work with instance and they work with durations. But you'll often find, especially with some of the some of these calendars which don't necessarily align well with the Western calendar, that they don't necessarily convert very easily,
Hmm.
or you can do certain things like adding a few days, but it can be difficult to do a lot more. Um, and a lot of operations you think would be easy to do are actually not easy to do. And this is where I'm saying I've made a lot of opinionated assumptions. So if I say I want to add a day to something, I can add a duration of a day, but I can't add a period of a day. And
Hmm.
it won't let you, there are certain objects here which won't let you add a period of a day. And
Uh-huh.
so if that's the case, I'll convert it to a duration of a day and add that. And the reason is that a period of a day can vary.
Yeah.
So
Not always 24 hours.
if I go from midday to midday the following day, noon, so that's 12:00:00 all the way down. Um, from one day to the next, if there happens to be a leap second in between, then it's going to be 1 second more than 24 hours. If you change to or from daylight savings, you could get an extra day, an
An
extra
extra
hour,
hour. Yeah.
or an hour
Or
less.
yeah. I mean, working with time is like so tricky. I don't know how we get it right at all. It is so tricky because you think,
We use it in language all the time. We expect to be able to use it. Um, and this is why, these libraries get so incredibly complex.
and how you have to use them. Like you have to, there's like a book you have to read about how to use them. Like if you're like, how do I get the first second of the day? Like that's a non-trivial problem.
And this is where I've decided to make a lot of assumptions because
Mhm.
if I say the first second of the day, 99% of the time, I mean a certain thing.
Yeah.
Now, there are other occasions where that doesn't quite align. How does that work? And what I've decided to do in those occasions is go with the natural presumption, but still allow access to the API to get through to the precise version. But if you make everybody use use the full API every single time they want to do a basic thing,
Yeah.
it gets in their way. And that's really what I was getting at when I was talking about um, wanting to, make these presumptions or set sensible defaults for things, because people are always wanting to like do the basic thing. I want to do this thing tomorrow, which means 24 hours from now. Well, it doesn't. It actually, if daylight savings happen, then it doesn't. Um,
Right.
that
It
sort of
means
thing.
anywhere, it means 24 hours or less from now. Tomorrow is not, it's
No,
not,
sometimes
not a
tomorrow is more than
realistic,
24 hours from now.
Yeah.
well, or less, right? Like if
Yeah.
you're, yeah, it's 5 p.m., you're like, I guess I'll do this tomorrow. Well, tomorrow is 9 a.m. the next day. That's,
Right,
The
sure.
thing I
Yeah.
enjoy is like when I'm going between Europe and London, or if you're in the US, you're going from East Coast to West Coast. You're
mm,
setting up calendars, you're traveling, and you set up the calendar, the from calendar where you're leaving from, and then the to calendar. And then it's fun and games because when you land there, you have to make sure that you now know that you're in the to calendar and that all from calendar is it's like
I
and
missed
it's
the
like in
flight.
Europe to London it's like 1 hour, but it's like so hard to get this right.
The
I'm
one
finding
hour
that
is
Apple's
actually
getting better
worse.
with it. Sorry, Nick,
Yeah.
what was that?
Oh, I missed a flight. I was living in Nevada and flying out
Right,
of
right.
Utah, and there was a 1 hour difference that Google Calendar, it takes these things into account, but that's new. Didn't used
Uh-huh.
to.
Mm.
Uh, I missed an entire flight. Had a surprise weekend in Salt Lake City.
That's nuts.
We
I'm
had
finding that Apple calendars are doing conversions for me more transparently. Figures out where I am at the moment. I put in times, and when I go into the office, which is in Europe, everything will have been converted for me. I did find that even using Apple Calendar a few years ago, it didn't always work. Sometimes I'd have things in the wrong time zone, and or it would be continuing to tell me that something is at 9 a.m. on this day, and no, now it's really at 2 p.m. or something like that. Um, it I'm finding that a lot of these tools are getting better, I think, because companies that work on user interfaces like Apple does are trying to work with people a lot more. Um, and that's the thing. You can't avoid this stuff. You can't just say, well, it's too complex and only professionals who work with, who code in time can work with this, because that's not reality. Everybody works with time. Everybody has to work with time, and we can't just avoid it. And you can't say, well, let's go with the sensible defaults, because people run into those edge cases, and you must have workarounds for it.
Hmm.
The first time I encountered this was early 2000s, working on the database for the company I was at.
Y2K by any chance?
Was that sorry?
Post
Y2K.
Y2K.
It was post Y2K. But we were writing code in Brisbane, Australia, and that's in a state that does not have daylight savings. And one of our customers was in California, and they were losing certain times, and I was tasked with, fixing whatever this problem was. And it turned out they were inserting a date time into the database without a time zone attached. And the time that they were that's right, the date time they were receiving had come from the UK, and they were putting it into their database. And the specific time, which the specific record that they were complaining about had occurred at a certain hour in the UK, and it didn't seem to be a big deal, but it was trying to change the time on them in San Francisco. And it turned out that that's because it occurred at what is it, 20 past 2 on the night when daylight savings
This
came.
is entering into coding horror territory.
Yeah.
And so the time that was showing up from the UK actually wasn't a time that existed in San Francisco, because
It
it go
never
from
happened.
2 a.m. to 3
This
a.m.
event never happened. It never happened. It
And
didn't.
so the way that the Java libraries handled that was to just jump into the next hour.
Mm,
But
And
so
then
that's an
when
assumption though,
it came
right? Like,
back out, it would be changed.
but that's an assumption. That Java library is making an assumption. So that's dangerous. That's a dangerous assumption.
This was the first time I ever hit time. Yeah, it's taught me never to make presumptions about time. And every time I thought I really had a handle on this stuff pretty well, I've learned that no, there's more to it than had ever anticipated. The further I dig into time libraries, the more complex they become each time. Um, but I really have to hand it to the implementers of Java's time libraries now. They are very, I won't say completely comprehensive, but they cover most things that you're likely to encounter.
mhm.
And a lot of this came out of Joda time.
It's the
And
same
it's
guy,
great
isn't
that
it?
it's built into the language now, which means that, for the majority of people working on Clojure anyway, they're going to have access to it as well. So I'm really pleased that it's, that there's a good solid library that Ambrose has written.
We had on a repo that had barely anything to do with time. It just opened the repo. Someone had put in the like largest heading of Markdown, "Time is hard," in quote. And it was the first thing you'd see when you open the repo was "Time is hard." So maybe this will make it not hard. Maybe you finally fixed it. You finally fixed time.
I've fixed it for my particular use case. It'd be great if other people used it actually, because then uh, I could get feedback on like what do people want to do with this stuff? How do they want to work with it? And in my case, that um, I'm often getting times as strings. We see this in JSON, we see it in files, like it uh, over the network. It's usually going to be serialized out as an instant string, that kind of thing. And I need to do like adding 5 seconds to it, or compare, is this after that, or something like that. And this is actually my biggest use case, is converting to and from strings.
Mhm.
And like, sure, you can format and parse, but then you discover that one place was formatting with 3 decimal places on the seconds, and another was formatting on with 6. And then Java's parsers, you've got to manually build those. You can't use one of those string
Generic ones.
specifications
Yeah.
for it. You need the API to build up for like optionally the fractions of a second, um, or optionally down to the thousandths, or optionally down to the millionths, or maybe there's just no fraction of a second at all, and you might receive any of them. And how do you pass that? There's no um, there's no way to do that with the time format string.
Yeah, it's nuts. Yes.
So sorry, I
Um,
didn't mean to focus on that particular library.
No,
I've got
it was
memories.
cool. You did not actually show us your editor setup, but
Well,
we
the
can.
editor is just Emacs. I like Vim, but I find that Vim just doesn't have the The integration of par_edit into Vim is actually my biggest issue. Using a leader and less than, greater than to slurp or buff. And also there's a timing issue. You hit leader and something. If you hit it too quickly, it doesn't pick up what you're doing properly, and it thinks that you're actually trying to type something else in. So I found that the timing delays in Vim and the key bindings for certain operations were just very annoying. And Emacs was a smoother experience for par_edit. And then, I've used a number of REPL integrations. I don't use REPL a lot when I'm coding, but occasionally I want it. And I found that, things like Fireplace were not as easy to use as with Emacs. And I also like having an editor that I can use at the command line. While when I'm using code, I like to have numerous windows open all at the same time. So with Emacs, this is a GUI Emacs, so I can just have multiples open at the same time. But the nice thing is that they're all linked because it's the same application. So you can
Right.
see I'm highlighting in both windows at the same time.
So do you use
Paula, what
Ethernet?
is FlyMake? What is FlyMake?
Fleming also.
Sorry,
What is FlyMake? I'm sorry.
yeah. Yeah, what is it?
It
It's on your screen.
it'll
Clojure
run
FlyMake.
something like if you have a linter or something, it'll run it, you know, whenever you make changes, and then it's got ways of integrating it back into your editor, like squigglies or something.
So you don't use the REPL a lot. I feel like a lot of our guests are kind of REPL only people. Uh, or do you what's your flow uh as someone who's not using the REPL a lot?
So my flow tends to be that what I was describing earlier, where I do wishful coding. I will write a function that I want to do, and I'll write it as simply as possible, saying, and at this point, X equals magic. Where magic is the thing, some structure around something, and I just write that. And then I say, okay, now I need that function, and let's go in and do that. And I'll get something working this way. And occasionally, if I've got something fancy going on with the data structure, like recursive reducers or something strange, I'll try playing with that at the REPL, but it'll be a clean REPL, not attached to my editor. I'll occasionally do something in a REPL that way, but I'll write out code like this and get it working. But then typically I'll go for a walk or a run or a swim. And while I'm doing that, I'll think things through. And if it's something simple, it won't be an issue for me. But when it came to like this library, it stayed with me and I'd think about it a lot. So Rich Hickey likes to use a hammock. I like to use exercise, but I think things through. It took me a few weeks of thinking through what I was doing here to write all of this. And on this particular library, and I could refactor it out to better structure it in separate files, but a lot of the structure occurred like thinking it through. And I find that if you devote that sort of time and mental energy at something, that when you come back, you can write it out and it works. And I've not found that to be as effective in other languages.
But
Yeah.
you're not using the REPL in that. You're just coding it and then take
Yeah.
a break, and then you come back and you've got better code.
Now, occasionally I'll use a REPL. I will test out an idea sometimes, but generally I write and, I could be using Notepad, but um, yeah, I spend most of my time thinking. I took that to heart, and I'll try to structure I like building my data structures and sorting out how they work and what's interacting with them and how, and then I build out that way. But yeah, I'm really not a REPL-driven developer.
Hmm.
I find myself doing the what you call wishful coding, and I'm trying to remember if I did it before I worked with you or if
I
You
do
picked it up from her.
explicitly
Yeah.
remember some code that we were looking at in Asami together, where I did that in front of you.
Yeah. And I was like, oh yeah, you could just like build it backwards. And I do find when I'm working, I'm building backwards. It's almost, it's not test driven, it's different, but you're starting with the thing that you want and
Yeah.
you're backwards to produce it.
So test driven is a little that way. If
Yeah.
I don't do a lot of test driven. I do see a lot of people um, talk about test driven and don't. They have
Yeah.
a lot of tests, but they don't drive it with tests. But I do like that approach in that
Results, result driven.
uh, I'm
Yeah.
trying to get to here.
Yeah.
So let's make that work. I tend not to be test driven though, because sometimes oftentimes in implementing things, I realize that I hadn't thought through all of the issues properly. And I need to restructure, I need to change what's being returned from something, that sort of thing. And as a result, the tests have to change as I'm going. And I've found that, I'll be refactoring those constantly as I'm trying to implement things correctly. And that refactoring just seems like busy work. It's not useful. But I know what I'm trying to get to and how and why. And I'll be wrapping things a particular way, say, and that wrapper needs to change. Um, so I'll tend to write a lot of tests when I'm done, and I try to be comprehensive about that. But I'm not so um, uh, I'm not very good at writing the tests before I've done something, unless
I'm
it's
yeah.
unless it's like an API style thing where it's going to be predefined for me, or I need people to be able to use it a particular way. Then that sort of thing, I'm happy to write a test up front.
Yeah, I think that the effective part of the test-driven development is because like and no one does it. Like no one really does. My coworkers and I were just talking about like the older we get, the more we feel like test-driven development is very sensible, but we don't want to do it. Uh, and it's really what it's about is when you start with the result that you want. It's like my son just figured out if he starts at the end of the maze and goes to the beginning, then he always beats the maze, you know? And so when you're starting with the results and working to produce the results, it does have it feels more assured that you'll get there. And
You're focusing instead of it's so easy to just be like, oh, maybe I'll have this thing and this feature, and you're kind of working on five things at once. And
that's this wishful coding flow has a very similar it's a similar flow without but instead of starting with the data that you're trying to produce, you're starting with the function to produce the thing that you want. Uh, and we have a question from the chat for you from
yes.
Yo-Yo Broker. Uh,
Mhm.
would Yo-Yo Broker would like to ask Paula about her approach to upskilling. Does she still explore new languages these days? How does she decide which skills to advance?
Um, Not so much in new languages recently. Um, so this past year, a lot of my spare time is in study. Um, I'm a full-time student.
Of what?
Um,
Yeah, what are you studying?
um, I'm I'm a PhD student in computer science.
Hmm.
So
See,
I
doctor.
started. What's that, sorry?
You're going to be doctor. You're going to be doctor.
I'm only doing it so that, when I graduate, I'll be able to say, trust me, I'm a doctor. The I actually started postgrad in Australia. And when I moved to the US, I tried to keep it up for a little while, but it was just too hard remote, and my children were very young. But they're all away. My youngest is now about to start year 12, and I have two out of school. One of them's about to start his final year of physics. He's just graduated from a film degree, which he was doing at the same time. Um, so he's got one more year to go for physics. And I'm actually at the same university with him.
Oh,
Oh, fun.
I try not to like interrupt him too much because I know he's busy and he doesn't want me hanging around. But it is nice to it's an hour drive away. So I drive down for classes. Some of my classes are over Zoom, but uh, I like to um, I like to go to them in person where I can. Um,
so you're physically on campus for this.
I'm physically on campus. I have a supervisor and a lab and everything.
How
Um,
does how does it feel becoming a on-campus student?
Do you feel like a lowly grad student, like being
no,
used
not at all.
for cheap
I
labor?
am a similar age or older than most of the academic staff,
Mm.
and they're all aware that I have a lot of experience as a software engineer. And so, sometimes they'll defer to me, which seems really weird. The students all presume I know what I'm talking about, which they almost treat me as staff sometimes. I'm often approached after classes to like, can you help me out through this? And um, so no, I don't feel like I'm a lowly grad student with everybody else, even though I definitely should be in that situation. Um,
So what's your research area, Paula?
AI. So I'm trying to work with a transformer architecture, incorporating semantic web. Um, I want to incorporate ontologies into transformer reasoning.
Wow. And like owl rules and stuff?
Yeah.
Oh,
Well,
that's
not
cool.
rules, but the ontology aspect of it. Yeah.
Oh,
Yeah.
uh
And there's already work going on in that area where, um, you know, reading an ontology and incorporating that into the flow. But I want to bring it much more into the each step of the transformer pipeline.
Mm.
Um, I
To
I
help with the
haven't proven
training
it, but
or just in
I
the
have a
inference?
suspicion that I can keep it better aligned as it's going through um, at each stage. Maybe not. I'm still working on this, but the goal of it is to better apply ontologies when doing reasoning with an LLM. In
Hmm.
my case, the application is around interpreting clinical notes, and the
So it's
ontology
gonna
can only do.
you're trying to you're using neural networks,
Mhm.
which kind of they learn what they learn, right? You just do your best to get them to learn. And but you're trying to incorporate structured knowledge into that like more connectionist approach, like more of like a symbolic approach, like combine the two together. Is that the idea?
Yeah. Um, at each point through it, there is a symbolic representation of the data which has come in. And we're really familiar with processing um, text, images, sound through these pipelines, large language models being a common example of that. But in each case, what it's done is it's taken a symbolic representation, a vector representation of the data that's come in, and it has encoded semantics into that vector.
Hmm.
And then that's what's going through the pipeline. And it really does take a lot of the data that came in originally and at each stage, it reincorporates it, trying to keep it aligned as it's going. And when it comes to large language models, it's also taking everything that's previously been said and bringing that in at each point in the pipeline as well. But I'm trying to tweak part of that process to take a symbolic representation of the ontology. Like, the ontology says these are the classes of things you have, and these are the properties that describe this class.
And they
Um,
relate in this certain way.
and they can only relate this way. To have an encoding of that and to use that at each point on the way through. To a certain extent, just throwing your ontology in with your query can do that, but
Okay.
I'm trying to make it more efficient, and I'm trying to keep it really well aligned with the particular needs of the application. And like I was saying, I have this medical application that I'm trying to apply it to.
Okay.
You
And
are a sensible person whose judgment I trust. Sorry, Eric, did you
no,
have
go
a
ahead. Go ahead.
I have kind of a long question.
Sure.
Uh, I guess I want to hear, since you are a sensible person whose judgment I trust, who is working in what people are calling AI.
Mm-hmm.
And I want to know what you think is missing. What are the broader discussion about AI in the world and in programming? What do you think we're getting right about it, and what do you think we're getting wrong about it?
Well, it depends on who you talk to, because different people have different views, and some of those views I agree with and others I don't.
Which ones do you agree with, and which ones do you not agree with? Or I guess which ones do you agree with?
Let's see. That's hard to say. I'm developing a picture of it over time. Um, and I mean, it's a numerical model,
What
and
is
we need to be careful about the anthropomorphizing of it, which I think a lot of people get wrong. We talk about how it tries to do this thing, or the recent outcome from the Anthropic Alignment Group. They're talking about how these models have, they attempt to keep themselves on, and they, when provided with access to fake emails in this organization, and said, now this engineer is going to turn you off, and it wanted to use emails from that engineer that indicated that they were having an extramarital affair to blackmail that engineer into not turning them on.
real?
That kind of thing. Um, I think there's too much anthropomorphizing going on there.
Well, you say that until your colleague has an extramarital affair with the model, and then it's
So, and I think that people trust it too much. On the other hand, I also think that it can be trusted nearly as much as talking to a person. And this comes back to that question I was asked a minute ago, how do I upskill on things? Well, lately I tend to upskill using LLMs. They're a great way to distill a lot of information. You can't rely on it. If you do everything that it tells you verbatim, things go wrong. But it's like talking to someone who knows the subject pretty well, but still makes mistakes. If a person is trying to tell you, you want to do this, this, and this, and here is how you call the API, if they're just doing that off the cuff, they might have got the arguments in the API wrong. And if you talk to an LLM, they'll generally have the structure correct, but they might get the arguments in the API wrong. So it's a lot like talking to a person in that regard, in which the recall is pretty good, but not perfect. But that makes them a really good tutor, a non-judgmental tutor. So I like to go back to original sources, but I find that stuff can be really hard to work through. Like web pages or books or whatever, original documentation. I want to have that on hand but I'll generally have an LLM lead me through it. And then I can, if I've been given the overall picture, I can then look at the details in documentation, that sort of thing. So that tied back to the earlier question. But, in general, I find that these systems are really good for condensing information into one place and making it really accessible. I do think that they can reason to a certain extent, and the more advanced models are definitely getting that way. Some of the research which is coming out showing that they're iterating on symbolic representations of concepts, and that iteration, takes concepts, changes it, sometimes merges, sometimes splits, and what comes out at the other end appears to have been reasoned through. And so I do think that there is an element of, the processes that biological systems use in thought, but we're a
Doesn't
long
that
way short of that.
doesn't that lead to hallucination and model disintegration though when it's training on itself? I know
Oh,
that
no,
pre
no, I'm not saying training on itself. I'm saying iterating on itself. So
Talking to itself, basically.
yeah, it turns text or images or whatever into a vector, which is which tries to represent an idea. We'll map it to what humans call an idea, but there's semantic information in these vectors, and it will then process. It can loop through that, and that vector in thousand dimensional space or something will then start to change. And then, after processing it through a pipeline and coming back and reprocessing it multiple times, it can then turn that back into text or images or whatever. And you can see something based on this process, which we can think of as a form of reasoning. And in some ways, it does emulate what biological systems do in thought. And so I think it's disingenuous to simply say these are just a probabilistic way of generating text or images or something. I think there is something going in the direction of how thought occurs. It's a long way short of that, but it's certainly useful in many ways. But I think people get it wrong when they completely dismiss it as a numerical model. I think that people get it wrong when they say that it's thinking, but there is somewhere in between. I'm also skeptical of the way researchers are saying, well, we just need more of what we have,
Hmm.
because I think it's a part of, for people who are trying to get to um, general AI or AGI. I think that what we have today is part of that story, but I don't think it could get us there if we just do more of it. I think that there are some fundamental things that we've missed that aren't in there and that we would need to incorporate before we could get to that. And also the fact is that, we can take very small biological organisms and and they can do very intelligent, clever things. And they do it with far fewer neurons than, the elements that we're working with
And way less energy.
yeah.
and way less energy. I mean, I can solve a very difficult problem with the energy in a chocolate bar. And
And
in
that
fact, I
is
do.
much
But
lower than the AWS bill that it would
yeah,
require.
and even if we make our circuits orders of magnitude more efficient, we're nowhere near what a biological system can do. What are we missing? There's got to be some fundamental things that, we're completely missing.
I mean, to me, one of the things that's missing um, is like we have dedicated structures. We have specialized structures in our brains, and they're just now figuring out some specialized structures, right? Like transformers and attention and things like that are are specialized neural network for that task, right? But then they just make a really big one. And we probably have a lot more smaller specialized things and then ways of integrating them and working together.
You see elements of this in some of the systems which have been coming out, like DeepSeek, um,
Hmm.
had an interesting approach where they've pulled apart their their LLM into smaller LLMs which specialize in certain tasks. And then when you ask a question, it says, oh, this is best answered by that system over there. This is
Hmm.
best answered by that system. And those systems that then specialize in that area.
Right. And so they're much lower power. They require much less training because they're on a much they're very specific, right?
Yeah.
Um, I feel
And
like that kind of thing is going to be the future because we just can't spend so much power. Um, we need to like I actually I mean this is my opinion. I'm not that like researched on this, but I actually feel like something like GPT 3.5 was if you had multiple of them, each dedicated to a task, and you had them learn how to work together, like that would maybe do better than some of
Isn't
the
isn't
what's
that
that?
agentic? Aren't you describing what when people are talking about agentic AI, that's kind of what they're talking about, right? Is you have this like smaller ones that are working together on a task.
I don't know. When I hear agentic, what it means to me is that they have it actually do work, not just talk, not just chat.
Oh, I see. Okay.
So it means like you let it loose in your terminal and it'll
Yeah.
actually like compile your code and run it and see if it works and if look at the error message and then change the code and try again.
Give it your
That's
credit card. What can possibly go wrong?
and access to your email.
People do it, yeah. But anyway, I've got to go, unfortunately.
Oh,
So I'm
Ray.
gonna, yeah. But great to see you again, Paula. And
thank you, Ray.
I'm gonna have to buzz off, but obviously keep on streaming.
We
And
are we
Well,
are
it's been
past
a
time.
while.
Totally
I
wrapped
don't
up.
want to bore everybody.
No, Paula,
not at
I
all.
actually would love to keep talking. Not maybe not today, but maybe offline. I have a master's in artificial intelligence and like all the stuff you're saying just sounds super cool. I did RDF and the semantic web and all that too. Um, so love to chat more about that.
Sure.
Let's sign off on the recording.
Yeah. So everyone, thank you for watching. Um,
Thanks, Paula.
yes, thanks Paula thanks our guest for coming. If you're interested in this kind of discussion, please subscribe. Then you'll know when we're having our next show, and you can jump in the chat and ask all the questions you want. So thanks everyone. See you later. Bye.